today we are going to discuss about the general properties and periodic trends of group 1 elements and the chemistry of lithium. So, generally this particular topic is taken from the BSc first year first semester chemistry paper, and generally in this particular topic where we are discussing about the general properties and the periodic trends of the particular group 1 elements consisting of the various like lithium and sodium, potassium, rubidium and cesium and francium. So, these are the elements and how these elements are behaving in the groups and how these elements are behaving in the period. So, we will going to discuss about in a particular manner, right. So, first we will see the what are the elements consist of this particular group 1 elements. So, first we will discuss so what are the elements present in this one and what are the electronic configuration of these elements. So, we will go through that particular chemistry, right. So, generally in the periodic table we have divided into 4 blocks here, the S block elements, P block elements, D block elements and F block elements. So, in the periodic table in the left side where it is consisting the S block elements, and in the right side we have the P block elements, and in middle we have the D block elements and F block elements here, and where the topic which we are going to discuss today is taken from the S block elements here. So, in this particular compound where in this group we have there are 6 elements are there: lithium, sodium, potassium, rubidium, cesium, francium. And if you see the atomic number of these elements, the lithium atomic number is 3, sodium atomic number is 11, potassium atomic number is 19, rubidium atomic number is 37, cesium it is 55 and francium is 87. And if you see the electronic configuration of these elements, the lithium atomic number is 3, which is you can write this electronic configuration by taking the helium inert gas configuration helium 2s1, and sodium is neon 3s1, potassium argon 4s1, rubidium krypton 5s1, cesium xenon 6s1 and francium radon 7s1. So, if you observe the electronic configuration of all these elements, group 1 elements, so the electronic configuration, the outermost shell is having the s orbital, and you can see the different shells. So, for the lithium it is 2s1 and for sodium it is 3s1. So, you can observe in the last shell or the outermost shell is having the one lone pair electron here. That is why these the general electronic configuration of these element is ns1, and that is why it is comprises in the S block elements, because the penalty element penalty electron is occupying the S block. That is why it is called the S block elements here. Now, if you see the properties of S block elements, so first we will see the atomic number. So, where the atomic number is going to increase from left to right here. So, where the lithium is atomic number is 3 and francium atomic number is 87, means where the atomic number is going to increase from top to bottom in the period here, right. Next, relative atomic mass. If you observe the atomic mass, with increase of the atomic number, the atomic mass will be going to increase. If you take lithium, its atomic mass is 6, and sodium its atomic mass is 22, and potassium atomic number is 19 and the atomic mass will be the 39, and rubidium its atomic number is 37 and its atomic mass will be the 85, and francium it is 223, means where the atomic mass is double to your atomic number. Next, abundance in the earth crust. So, group 1 elements generally they will available in the earth crust. That is why we call these are the alkali metals here, and you see the abundance of these group 1 elements. Here generally the abundance, the sodium is a most abundant element in the earth crust here, and if you see the value of this sodium abundance is parts per million. It is noted in the parts per ppm, parts per million here, and its value will be 22,700. And after that, the second most abundant element in the group 1 element is potassium, and it will be available in the value of 18,400 here. Later, the next abundant element is rubidium, and its value will be 78, and then the cesium. Okay, the cesium abundant value is 2.6 here, and francium it won't available in the earth crust. That's why you can see the value of these abundance of the particular group 1 elements here. Next, the periodic property, you can see the atomic radius. So atomic radius means where the radius or the distance from the nucleus to the outermost cell is called the atomic radius. And if you see the atomic radius of various elements in the group 1, so you can see where if you observe the atomic radius is from top to bottom, it is going to increase here. So if you see the lithium atomic radius value will be the 152, and for sodium it is 186, and for potassium it is 227, and for rubidium it is 248, and for cesium it is 265. So what do you observe from these values here? So where the atomic radius is going to increase from lithium to cesium. Next, ionic radius. So with respect to of the atoms, right? So when you remove the outermost electron, then it becomes ion, right? So when you remove the electron, so it becomes ion. Then the ion, it will be ionic radius also going to change according to their size here, right? So for example here, if you take lithium, so its value will be 76, and for sodium its value will be 102, and for potassium it is 138, and for rubidium it is 152, and for cesium it is 167. So here also same trends will be observed as your atomic radius. So atomic radius and ionic radius both will be going to increase from top to bottom, that is from lithium to cesium. Then the melting point. So here the melting point, generally you can observe that the melting points are decreasing, where the above properties are going to increase from lithium to cesium, and the melting point is going to decrease from lithium to cesium here. This property is observed due to the loose packing of the crystals here. So generally this particular elements, lithium, sodium, potassium, rubidium, cesium and francium, they are having the body center crystals here, BCC crystals. So in this crystal the packing will be the very loosely, and you can see the bonding between that particular cell is it is weak bonding here. So due to this weak bonding nature, where you can see the low melting point of the particular elements here, that's why you can see the lithium is tightly held the cell here, and with increase of the size, where the particular cell bonding interaction between the cells is going to decreases here. That's why you can see the decrease in the melting point of particular elements here. So the melting point values will be decreases from lithium to francium here. And then the density. So generally here the density is going to increase from top to bottom, that is from lithium to cesium here, because the density where there is particular lithium is a less denser element, and the cesium is a more denser element in the group 1 elements here. And next, the ionization potential. So the definition of ionization potential is where the elimination of the removal or the elimination of the outer shell electron, the last electron removal is takes place by applying some kind of energy, that is called the potential energy. So how much energy is required to remove the outer shell, outermost electron here? So depending on that, the potential energy is impact on your ionization energy here, right? So generally here the lithium lithium where it is very small element. So, it will be the outer shell electron is tightly held with the nucleus here, means the nucleus will be having some attraction on the outer shell electron here. That is why it is difficult to remove the electron here from the outermost shell, and with increase of the size of the particular elements, potential energy is going to decrease here, because the number of cells is going to increase. That is why the distance of the outer shell electron from the nucleus is going to increases. So, where you can see the outer shell electron is very far away to the nucleus. So, the nucleus attraction is decreases on your outer shell electron. That is why you can easily remove the electron from outermost shell here. That is why the ionization potential is going to decrease from lithium to cesium, means you can explain this ionization potential depending on their size here, right. So, with increase of the size of the element or the atom, the ionization potential energies will be going to decreases. Next, you can see the oxidation states here, right. So, in the oxidation state, so generally the group 1 elements electronic configuration, the general electronic configuration of group 1 element is NS1. So, NS1 means in the outermost shell is s orbital is having 1 electron. So, it can easily remove the, right, it can easily donate the outermost shell electron here. That is why it will be having the +1 oxidation state, and the stable oxidation state of group 1 element is a +1, right. So, you can see the most stable oxidation state only +1 only, because the other group elements is having the more than one oxidation state, but the group 1 element is exhibiting only +1 oxidation state, and it will be stable in this particular oxidation state here. Yeah, softness and the low melting point. So, generally you can see where the bonding between the elements electrons is weak here. You can observe the weak bonding between the electrons. That is why the metals, the group 1 metals are very soft in nature. This softness is due to the weak bonding interactions between the electrons here. Next, the chemistry of lithium. So, generally the lithium is a first element in this particular group 1 elements here, and the chemistry of elements involves a detailed study of the lithium, where the lithium, so the lithium first discovered by the Berzelius in 1817 here. So, when these particular scientists Berzelius and Affedavison, these two scientists are, when they are analyzing the minerals of the lithiums like petalite and spandium. So, these two are the major sources or the major minerals of the lithium here. So, when they are aimed to analyzing these two minerals, they are found the lithium in 1817 year here, and you can see the important minerals of the lithium. So, the minerals of the lithium, there are various minerals are available. In the first one is aluminosilicates. So, you can extract the lithium from these aluminosilicates here, and in this aluminosilicate category we have three minerals here, lepolite, where its formula is lithium, sodium, potassium taken twice, aluminum silicate here, and lithium, sodium, potassium, and fluorine and hydroxide here. And in this particular combination is having the 2 to 6% of the lithium. So, very little percent of the lithium will be obtained from this lepolite source here. Next, spandium. So, the spandium, where this particular formula is lithium aluminosilicate, lithium Al Si2O3 taken thrice. So, this is the spandium molecular formula here, and it is consists the lithium percentage is 4 to 6% here. Next, petalite, where the petalite its molecular formula is lithium aluminum silicate Si2O3 here, and it consists 2 to 3% of the lithium. So, from these minerals you can extract the lithium here, and the phosphorus minerals also available, and you can see these phosphates minerals, right. So, where these are containing the somewhat more than your aluminosilicates here. Next, the compounds of lithium. So, generally the lithium is having the reactions with some other elements and compounds here, and it will be forms the variety of compounds, and how they are going to form the variety of compounds with what are the elements and some other groups here you can observe. So, first we will see the formation of that particular lithium oxide. So, when the lithium is treated with the oxygen, where it going to form the lithium oxide, and lithium carbonate, when the lithium carbonate is decomposed into lithium oxide and carbon dioxide here, and lithium hydroxide, this is also going to form the lithium oxide. When this lithium hydroxide is heated, then it is going to form the lithium oxide, and water will be going to form as a byproduct in this particular reaction, and you can get the lithium oxide by reacting of your lithium nitrate. So, where the lithium nitrate, 4 moles of lithium nitrate, when it is going to react, so it is going to form the lithium oxide and nitrous oxide NO2 and the oxygen, right. The oxygen is going to evaluated in this particular reaction here, and here the lithium hydride. The next compound of the lithium is a lithium hydride. So, here the lithium hydride, generally it is obtaining by the heating of the lithium with the hydrogen gas here. So, where the 2 moles of lithium is treated with the hydrogen gas, then it gives a 2 moles of lithium hydride, and when this particular lithium hydride is reacts with the water, so it is going to form the lithium hydroxide, and where it evaluates the hydrogen gas. That is why when we perform the preparation of the lithium hydride, so take care that there is no moisture or there is no water in that particular reaction surroundings here, right. Next, when the lithium is treated with the aluminum chloride, it is going to form the lithium aluminum chloride, where the lithium aluminum chloride is a strong reducing agent here. So, where it is having variety of applications in the chemistry here, right. So, 4 moles of lithium hydride, where it is going to reacts with the aluminum chloride, and it is going to form the lithium aluminum hydride, and it is basic nucleophilic. It is nucleophilic reducing agent, and it have the variety of applications, like it reduces the carbonyl compounds and it forms the compounds here, and lithium nitride. So, when this particular lithium is treated with the nitrogen gas, it is going to form the lithium nitride. 6 moles of lithium is going to reacts with the nitrogen gas, it is going to form the 2 moles of lithium nitride, 2Li3N. Next, the lithium fluoride. So, like your lithium nitride, so you can produce that particular lithium fluoride by treating with the hydrogen fluoride here. So, here the lithium nitrate, when it is going to react with the ammonium fluoride, so it is going to form the lithium fluoride here, and you can see the ammonium nitrate as a byproduct in this particular reaction here. So, in this way you can have the variety of reactions with the nitrogen here, and the lithium chloride. So, generally the lithium chloride, when it is going to react with the chlorine, right, here the 2 moles of chlorine, when it is going to react with the chlorine gas, so it is forming the lithium chloride here. So, in this way you can form the lithium chloride, and lithium chloride generally you can abstract the lithium from this lithium chloride, where it is acting as a ore here. Next, lithium nitrate. So, the lithium nitrate can be obtained by doing the reaction with the lithium carbonate here. So, when the lithium carbonate Li2CO3, when it is treated with the HNO3 nitric acid, so it is going to form the lithium nitrate, and the hydrogen and carbon dioxide is a byproduct here. And further, this lithium nitrate upon heating, so it is undergoing the decomposition and it is going to form the lithium oxide, where the lithium compound of this one. So, the lithium nitrate is going to form the lithium oxide and the nitrogen oxide, and the oxygen is going to evaporated in this particular reaction here. Next, the lithium carbonate. The next compound of the lithium is a lithium carbonate. So, the lithium carbonate, it can be prepared by treating with the lithium sulphate here. Lithium sulphate, when it is treated with the ammonium carbonate, it is going to form the lithium carbonate, and ammonium sulphate is a byproduct in this particular reaction here. And see that when this particular reaction is done, so if any moisture or any water contamination is there, so this lithium carbonate further it undergoing the reaction here, and you can see the formation of the variety of the compound here, where the lithium carbonate upon reacting with hydrogen, water and carbon dioxide, so it is going to form the lithium carbonate here. Next, the special characteristics of this lithium. So, when you see the lithium in this particular group 1 elements, so it is having some special properties here besides the other elements like sodium, potassium, francium, cesium. So, it is having some special characteristics here. So, generally this lithium is exhibiting the diagonal relationship of the lithium with magnesium. So, what is diagonal relationship? So, generally in the periods, right, the second period elements of is going to form the diagonal relationship with the third period second element here. Second period element is going to form the diagonal relationship with the third period second element here. So, where this particular lithium, it is a second period element here. Second period element, it is going to form the diagonal relationship with the third period second element, that is a magnesium here. So, due to this diagonal relationship, the both atoms, both the elements are exhibiting the similar properties here. Both are exhibiting the similar properties here. So, you can see this diagonal relationship, some anomalous properties here. So, you can see the anomalous behavior of the lithium. So, it is more hard and ductile here. So, generally group 1 elements are ductile metals, and these are malleable metals. Ductile means you can draw this metal into wires or the pipes here, and these are the malleable. Malleable means you can draw these particular metals into sheets here, right, and these are very shiny metals here. You can see the sodium, right, sodium, it is very shiny metal. When you freshly cut here, so it is having luster. So, like that these are having some special characteristics here, and it is not affected by air easily and do not lose its luster even on melting, right. So, lithium also showing the luster property, and upon heating also it will not lose the luster here, but when you expose these metals to the air, they will lose their luster, and it forms a nitrate even at ordinary temperature here, right. So, and it is least reactive of the alkali metals. So, when you see the variety of elements in the group 1 elements, so this lithium is the least reactive, and it reacts with bromine very slowly, whereas other alkali metals reacts with bromine violently. So, it is having the very less reactivity with the bromine here, and other elements like sodium and potassium, these are having the high reactivity with the bromine here, and the lithium hydroxide decomposes at red heat to give the lithium oxide. So, where when we lithium hydroxide, how do you get the lithium hydroxide? So, when you treat the lithium with water, then it gives a lithium hydroxide, and this particular lithium hydroxide upon the decomposition, it will be gives the lithium oxide here, Li2O, and lithium oxide is much less basic than oxides of other alkali metals here. So, generally the group 1 elements also called as the alkali metals here. So, because these group 1 elements, right, group 1 elements will be, they will react with the, or they will soluble in the water and they will form some oxides, and these oxides are basic in nature. That is why we call the alkali metals, right. So, here the lithium oxide is much less basic than the oxides of other alkali metals here. So, when you compare the other oxides like sodium oxide, potassium oxide, rubidium oxide, cesium oxide, the lithium oxide is less basic here, and the oxides and fluorides and phosphates and carbonates are insoluble. So, generally the oxides, fluorides means when they are reacts with the these particular elements like fluorides and phosphates here. So, these are insoluble in the water, right. So, like that, this is showing the anomalous behavior in the particular period here. So, in this way we can go through these particular group 1 elements and the properties of these elements. You can go, you can have the particular idea about these group 1 elements here. So, the important point in the group 1 elements are, generally in the group 1 elements where the lithium exhibits a diagonal relationship with the magnesium, and the group 1 elements are called as the alkali metals. Why these are called the alkali metals? Because when they are soluble in the water, the resulting oxides are basic in nature. That is why these are called the alkali metals here. And generally the lithium hydroxide, it decomposes at red heat to give the lithium oxide here.